Britain built the engine that helped win World War II. The name Rolls-Royce meant perfection. But in 1971, the company behind the Spitfire collapsed. Not because of war. Not because of competition. But because of one experimental fan blade that exploded during testing. And within months, Britain's greatest engineering empire was on the edge of death. If you grew up in Britain during the 1950s or 60s, Rolls-Royce was not just a company. It was national pride. The Merlin engine powered the Spitfire, the Hurricane, and the Lancaster bomber. During World War II, more than 150,000 Merlin engines were built across Britain and America. At one point, Rolls-Royce was considered the greatest engineering name on earth. But by February 1971, that empire was collapsing. One morning in Derby, men in dark suits walked into Rolls-Royce headquarters, carrying the legal authority to dismantle the company. Britain's most respected engineering giant had officially run out of money. So what happened? How did the company that powered victory in World War II nearly destroy itself in less than a decade? The answer begins with one of the most ambitious jet engines ever attempted. In the late 1960s, commercial aviation was changing fast. America was dominating the future with massive new aircraft like the Boeing 747, the DC-10, and the Lockheed L-1011 TriStar. Rolls-Royce knew something terrifying. If they failed to enter the American wide-body market, they would become irrelevant. So they decided to gamble everything. The engine was called the RB211. And on paper, it looked revolutionary. It used an advanced 3-shaft turbofan design that promised better fuel efficiency than anything General Electric or Pratt & Whitney could build. But there was a problem. Most of the technology inside the engine had never worked in a real passenger aircraft before. And the biggest gamble of all was the fan blade. Instead of traditional titanium, Rolls-Royce chose an experimental carbon fiber blade called high-fill. It was lighter, more efficient, and if it worked, the RB211 could dominate the future of aviation. There was just one issue. Nobody knew if the material could survive real-world conditions. But Rolls-Royce signed the contract anyway. In March 1968, they secured a massive deal with Lockheed to power the new L-1011 TriStar. It should have been the biggest victory in the company's history. Instead, it became the beginning of the disaster. Because the contract was fixed price. That meant, if development costs exploded, Rolls-Royce would pay for everything themselves. No protection. No escape clause. No safety net. And almost immediately, the problem started. The engine was overweight. Fuel consumption was too high. The thrust targets were nowhere near where they needed to be. Then came the test. That changed everything. In 1970, engineers performed the mandatory bird strike test. A dead chicken was fired directly into the spinning fan blades. At takeoff speed, the result was catastrophic. The high-fill blades did not bend. They shattered. The experimental carbon fiber exploded into fragments. And instantly, the entire foundation of the RB211 program collapsed. Rolls-Royce had no choice but to redesign the engine using titanium blades. But titanium was much heavier. Heavier blades meant heavier hubs. Heavier hubs meant heavier bearings. And heavier engine casings. The entire engine became larger, slower, and far more expensive. The redesign added roughly a year of delays. And millions upon millions of pounds in extra cost. But the contract price never changed. Now Rolls-Royce faced a terrifying reality. Every single engine they sold would lose money. By late 1970 the company was bleeding cash at an uncontrollable rate. Then the final numbers arrived. Development costs had spiraled from £75 million to nearly £170 million. Rolls-Royce was running out of time and out of money. The government was asked for help. But Prime Minister Edward Heath had campaigned on refusing to rescue failing industries. Saving Rolls-Royce would destroy his own political promises. For weeks, Britain hesitated. Then on February 4, 1971, the collapse finally came. Rolls-Royce entered receivership. The company that built the Merlin engine had officially fallen. The consequences were immediate. Production of Lockheed's L-1011 TriStar stopped almost overnight because the aircraft had been designed entirely around the RB211. No other engine could fit it. Not Pratt & Whitney. Not General Electric. Nobody. The failure of one British engine threatened an entire American aircraft program. At that moment, the British government realized something terrifying. If Rolls-Royce died, Britain could lose its independent jet engine industry forever. So Edward Heath made a decision he never wanted to make. The government nationalized Rolls-Royce, and then they brought back the one man who might still save the engine. Sir Stanley Hooker, a legendary engineer who had already helped save Britain once before. During World War II, Hooker looked at the RB211 program and immediately understood the truth. The engineering problems could be fixed. The financial disaster could not. So he simplified everything. Less ambition. Less complexity. Focus only on making the engine work. And somehow, against all odds, it did. On April 14, 1972. The RB211 was finally certified. Just over a year after Rolls-Royce collapsed. The engine that nearly destroyed Britain's greatest engineering company was now flying passengers across America. And in one of the greatest ironies in aviation history, the same RB211 architecture that almost bankrupted Rolls-Royce eventually became the foundation for the Trent engines, the engines that would later power the Boeing 777, the 787 Dreamliner, the Airbus A330, and the A380. Today Rolls-Royce is once again one of the most respected engine manufacturers on Earth. And every modern Trent engine traces its DNA back to the RB211, the engine that nearly killed the company. In the end, Rolls-Royce was not destroyed by a single mistake. It was destroyed by ambition, pressure, and a contract that left no room for failure. One failed blade test simply exposed the disaster that was already building underneath. And somewhere in Derby today, the shattered high-fill blade still exists. A reminder of the moment Britain's greatest engineering empire almost disappeared forever.